using this Windows.networking namespace. And as you most probably are fairly familiar by now, WinRT is the raw power of essentially the comm stuff from a few years ago, but exposed in a managed layer for C# or in JavaScript if you're using Windows 8 or C++ as well. So C++ works across the bottom two, C# works across those top two. The Windows networking stack comprises of sockets, TCP, UDP, HTTP as well, and we get this new bits and pieces called proximity. I touched on proximity a little bit last year in my Windows 8 session. It's a great technology and allows a whole range of different scenarios that we couldn't do just purely with a HTTP connection. And we're looking at now NFC, and NFC in the terms of being able to pair to peripherals, pair to other Windows phones. Also NFC in terms of wallet capabilities and smart card reads and things like that. And we also get Bluetooth. This is actually fairly unknown in terms of the Windows 8 space, but we do have full support for Bluetooth RF comm, specifically the serial port profile. So I'll show you a bit of that in a sec. So I'm actually going to just start right at the very basics. So we're going to look at sockets. A lot of people don't really use raw sockets because they don't have the need to. We get a lot of managed HTTP wrappers. We never have to deep dive down into the TCP socket layer. But a lot of what I showed yesterday, they're not necessarily TCP sockets, but they're a type of socket. And if you can understand using one socket, you can pretty much roll this out and apply it to any type of socket. So that could be a TCP or a UDP socket. It could be a Bluetooth connection. It could be a connection to a USB. The way WinRT has implemented sockets means that it's a unified asynchronous API. So if you call into the device, you connect to it, you then get a socket returned, and then you're just using data readers, data writers to pass byte data backwards and forwards. As I said before, we actually have 3 different types of sockets now in Windows Phone 8. We have the top one, which is Windows RT sockets, and these expose themselves in both TCP and UDP forms. Specifically, the namespace is windows.networking.something, and then the actual object themselves is stream socket for a TCP socket, or for a UDP socket is a datagram socket. And these are just representative of the actual standard names that were implemented in the protocols. We still have the system.net stuff, so if you're porting across legacy Windows Phone 7 apps or you're a Silverlight developer, everything that you had before is still there, so TCP sockets, the ability to multicast and listen, but no server. That's the important thing. We can't actually host content, so other devices can't subscribe to our app. We can only subscribe to other devices and other bits and pieces. Like I said, we also have access to the WinSock stuff as well. I'm not going to touch on the C++ stuff. I have sample code available if people do want to have a look at the C++ stuff, but I'll just kind of skip over that bit at the side. So what I want to do is I actually want to just load up this socket demo, very, very basic stuff, just to try and build up the layers of complexity here. And I just want to show you where we was in terms of Windows Phone 7 sockets versus where we've gone to in terms of Windows RT and the simplicity now of actually opening these connections and start passing information backwards and forwards. I'll talk you through the code, and then I'm going to attempt a demo. These are mostly my riskiest demos of the whole event. I actually thought it was going to be the USB stuff, but with the amount of devices that have got Bluetooth on and connecting to Wi-Fi and stuff like that, I'm really struggling to get a lot of these connections, so bear with me if things start to fail. So I'll switch across to my machine. So the first difference with the first difference is in Windows Phone 8 was we can actually create a server. Like I keep emphasizing this point, but having the ability to actually push information out is a big benefit to us. If we're doing gaming and things like that, we can actually start creating these peer-to-peer connections where we can have a host, a gaming host, and then other people can then start interacting with us. And it creates 2-player peer-to-peer scenarios. Couldn't do that before because we could only subscribe. We couldn't publish. So the first piece of code I'm actually going to show you is how we can actually start creating these connections. So the first piece here, this is our managed code. So it's actually completely wrapped in my custom class here. And I'm just going to jump down to the connection. So what we're doing is we're creating a new socket. We're telling it it's an IP network, so it's an inter-network is referred to in the classic C# sense. It's a stream and it's TCP. So this is the equivalent of the stream socket in the Windows RT namespace. We're then binding it to our IP address, so we actually just using standard .NET APIs to say, get the IP address that's currently attached to the network adapter, and then we're specifying what port we're going to use. The port obviously has to be known between both devices, and the IP address has to be known. This is the hard part about using raw sockets, is you have to bootstrap these devices yourself. So you need to connect, and then you would need to go across to your client and actually tell someone, this is the IP I'm currently on using this port number, and then you can start connecting. We do have broadcast technologies available, and I'll show you that in a sec. But in basic TCP/IP, it's a lot of hard work to get these devices connected. And that's why HTTP and the internet has got all of these layers on top of TCP to actually make things relatively simple. We've actually simplified the connections in Windows RT using the proximity stack, and in a later demo, I'll actually show you the benefits of this. So in the next line, we then start the socket, and we say, we call the listen method, and we actually just give it a timeout, and then we just get an event callback. As soon as we get a connection, we then get the arguments connected into us. So it was fairly easy in C# and Silverlight. In Windows RT, it's actually even easier. So we've reduced the line of code we need to 2 lines of code. So this top bit here is the listener. So we actually create a new stream socket listener. I'll try and zoom in. We actually enumerate through the IP addresses just because we need to find out what IP is actually connected. That's something that's mandatory with all of the connections. But this listener here, we're creating a new listener object. We're then just saying bind service name async, and we're giving it a port. We then get a callback argument when we get a connection, and that gives us our actual socket that we can start writing information to. Drastically simplified and a lot easier to actually start making connections. These are the benefits of these WinRT APIs, is we're taking what was maybe 5, 6 lines of code in classic C# or APIs that didn't exist or were over-engineered or complicated, and we're actually reducing them down into a consistent async connectivity piece, which maybe takes 2 or 3 lines of code to start connecting to different network stacks on different peripherals. The client is equally as simple in WinRT as well. So I'll jump to this code behind here. This top line, this top one is the Silverlight equivalent, the C# equivalent. So again, you'll see 4 or 5 lines of code to create the new managed socket, the same class as I had in the previous solution. And then I'm actually calling an async method that I've written up to say send using managed sockets, a whole load of code behind there to actually open the socket, start writing information, write data back to it. The next 2 lines, these are the native APIs. They're not abstracted by me at all. It's 2 lines of code. Open socket, start writing to it. Using C# async, it'll actually be able to write to it without blocking the UI thread, creating a very, very responsive application, very beneficial for phone apps as well. So the actual result of this, I'm going to attempt to just demonstrate how simple these sockets actually are, but actually showing you on 2 devices. Okay, let me switch to 3. Okay, hopefully you can see my 2 phones. Can you read the text on the screen? No. How do I zoom this in?
On the remote button there, you should have a zoom function. He did leave us the remote.
No.
He didn't. I can't see. Can't read it. So I'm going to have to get that, mate.
Okay, that's fine. I'll work around it. You guys most probably can't see what I'm doing, but what I'll actually do is, all it is the code I've just shown you is wired up to button click arguments. I'm actually going to start the listener on the grey phone, and on the blue phone is the client. So I'll just hit the WinRT socket. It says it can't find an IP address to bind to. Great, network issues. Okay, let's try again. Okay, I'm going to move on. So sockets, fairly simple stuff. In theory, it would work if 1,000 people aren't trying to connect to an access point and my phone can't pick up an IP address. This is going to make a very interesting rest of the demo because a lot of my stuff requires the Wi-Fi to work. Where this actually is starting to be beneficial is when we start to look at how devices start to expose themselves via networks. So specifically, there's a protocol that is used in a lot of home devices and a lot of enterprise devices as well called UPnP. And that actually uses the UDP protocol and then it sends a broadcast message out to your network. And it basically, every couple of seconds, it'll send this message over a UDP on a specific socket, and it will just ask devices to expose themselves. And it'll send a payload of information and just say, okay, tell us if you're online and tell us what you can offer us in your IP address. And it happens all the time. If you put a packet sniffer on your home network and you've got like a Belcare modem or a NAS or a smart TV and stuff like that, you'll see all this traffic just constantly flying around your network because the devices are talking to one another. So as soon as you turn your TV on or as soon as you turn your PC on, they're then exposed as network devices. We can actually start talking to them because the UDP protocols are fairly straightforward for us to actually start understanding once we get a grasp of how sockets are working. So I've actually got this code, which isn't open. We just open the project. So I've got this code, and it's actually using exactly the same sockets that I just shown you, but I was showing you the TCP version. I'm actually using, this room is jinxed, because David just had exactly the same issues that I'm having. It uses exactly the same codes that I was just showing, but uses UDP sockets on a pre-known IP address. And a pre-known IP address is specified within the UDP standards, the UPnP standards, and all devices that are currently exposing these endpoints push out to this IP address to a specific port number. They can respond to it. We actually then send, it would be great if I could show you the code, but we actually then send a piece of header information to say, this is what we want you to send back, and we get the responses from all the devices. When we get the responses back, we can then start enumerating through the header information. It's essentially a HTTP response that comes back. And within that header information, we actually get given the IP address of the machine that's exposing the properties. Let's see if it crashes again. And when within the IP addresses, once we get the IP addresses back, we then actually switch to TCP and we start making a HTTP call back to the device itself. So in the instance of my smart TV that I love to talk about all the time, I can actually send a header across, send a UDP broadcast, and I get the header information back. I enumerate for all the information, and one of the pieces of information I get back from them is the IP address of that TV and the URL I can start connecting to. If I connect to that URL, switching back to HTTP, so using a just basic HTTP client object, I then basically get the equivalent of a WSDL back, so a SOAP-style manifest file that tells me all the services that have been exposed on my TV. So I can then pass that using standard C#, and I can start seeing that my TV is exposing endpoints for changing the channel, changing the contrast, muting, and that kind of stuff. That my Belcam router exposes access points for storage and configuration, allowing me to write custom wraps around integration. And we start to see this a lot with audio-visual, AV type stuff, and the actual DLNA standards that's built on this technology. So in terms of being able to interact with our home entertainment devices and devices that sit around the house, this is actually an easy way to actually start making remote control apps with very little work. Okay, let's hope this code actually works. Okay, so what I've actually done, I've abstracted some of this code into a single class called an SSDP client. SSDP is actually the standard name for UPnP devices. It's the way it exposes the information. You can go up on Wikipedia and it's all documented on there, and which is where I found most of this information. So this is a WinRT API. I'll zoom in a little bit more so you can read that. So UDP uses datagram instead of stream socket. It's a new stream socket. I'm then subscribing to a message received argument. So every time I get a response on the UDP's broadcast, I can then just get that back to and then start reading the information. I then open the socket. So socket get output stream async. I give it the IP address. This is a broadcast IP address, so everyone knows what it is. It's part of the standard, and so is the port. So it's actually a constant across all of my devices. I then just basically send this header information. And this header information is saying, as a device, I want to know what all other devices can expose. So it's a discover request. It's actually formatted exactly the same as a HTTP request, apart from we're sending it over UDP. So you'll actually be quite familiar with this construct if you've ever spent any time inside Fiddler. I then write that to the stream using a data writer, which I'll cover in a sec. And then automatically, I'll get a response back. Because I send this broadcast out, all the devices on that device range will see it, and they'll start responding to me. That's when my event kicks in at the top here. So I get my message come in. I use a data reader just to read the binary object back in, and I'm actually reading it as a string, because I know it's coming back as XML. Sorry, it's coming back as a delimited text file. So I then just enumerate it through, because all I'm getting back are HTTP headers. It's HTTP over UDP. It's a very, very basic protocol to understand. I enumerate through all the headers, and I know one of them is then an IP address. So I actually then just say, I pass my dictionary back in. My dictionary of headers I've converted from delimited string into a dictionary. And then I actually use HTTP client. Hopefully we're all familiar with this. It's the stuff that we're using every day in Windows 8, ASP.NET. It's a standard C# client. And then I'm just saying, I want to use the location header that's passed back to me, get the stream, get the XML that's on that endpoint, and then start parsing it. That XML then just exposes, as I say, it's SOAP-based, exposes all of these endpoints, and I can start connecting to them. With that amount of code, I can now connect to my Samsung Smart TV, my Belkin router, my lights, all this kind of stuff to start controlling devices. Very, very easy way of integrating into home entertainment. I can attempt to run it. It's going to require a Wi-Fi connection, so I see what happens, and then I'll switch it across. It's quite interesting when you actually do this on a public access point, because a lot of PCs and stuff actually sorry, you're going to...
The Wi-Fi connection has to be with internet, or would be a router that you got next to you and connect both?
For this one to actually show, I need other devices on the Wi-Fi, so I'm trying to do it via an access point where other devices are connected, because even Windows PCs use this protocol, because as soon as you start sharing media, using Media Center and things like that, you're subscribing to this extension. But it doesn't have to be an internet Wi-Fi for this to work. It just has to have all the devices connected to it using Wi-Fi infrastructure. Okay, so yeah, this has actually done something, so I'll switch over now, and I can see if I can show it to you by lifting the phone up. So you'll see I've just run that code, and it's actually reached across the network. Oh, let's light down. Can we sharpen it up? The ironic thing is the phone I'm using has actually got display out, but they didn't give me the cable for it, so it would have been so much easier. Well, I'll read it to you, because it's obviously illegible on the screen. What it's actually got here is it's just a list box that I'm binding to. So every time I'm getting a new event respond, I'm actually just getting the XML back from that particular machine, and I'm just reading the top parameter, which is the manufacturer's name, and then the second parameter, which is the actual name of the device it's exposing. So it says Microsoft Corporation Windows Media Player sharing, Microsoft Corporation Windows Media Player sharing, and it says that 5 times. So that's anyone within this access point who's got their computer turned on and is using Windows Media Player. This is me connecting to your device with my mobile phone. So this is all just that code I've shown you. It's not a stub or anything like that. It's actually reaching out over just a public Wi-Fi point and connecting to devices. Okay, so that's all I'm really going to show on these sockets. I'm just going to flip back to some slides and just go over this code one more time, because it's an important concept to actually understand. So I've done the SSDP stuff. So basics of a socket. We just add the namespaces in. We say we new up the object. We tell it where we want to connect to, and we connect. That's simple. That's all it requires to take. If we want to add some extra security, we can actually do sockets over SSL, and this is on any protocol, so UDP or TCP. So when we're connecting, we can actually pass a third parameter in. So we can say hostname, service name, and we want to just up the security to SSL. This just uses the transport layer security to, as it would do on a HTTP connection, and just make sure people sniffing the network traffic can't see what you're sending backwards and forwards. If we want to send the data, we're actually using a data writer. So it's a nice wrapped abstracted API, very, very easy to use. So you new up the data writer, and you literally, once you've newed it up, you pass it the output stream of the socket. So a socket has two streams, input stream and an output stream, so it's obviously two-way. We pass it the output stream, and then we just have all these helper methods. So we can write an int32, a string, a byte array, a bit, an unsigned integer. There's like 50 different bits and pieces that you can actually write, and it handles all of the serialization for you. We can also just pass it a buffer. So if we've actually serialized something using JSON.NET, we can just pass it the output buffer from JSON.NET and just write it. We then call this store async that actually flushes what we've written to memory out to the network card itself. So it actually then just pushes it over the wire. If we're dealing with different devices, so maybe we're not connecting to another Windows device, the endianness may change because of the way the file systems are. So this is an issue if you're ever trying to connect to Android, so we can actually just change the endianness if we need to. Reading, again, we've got helper methods that allow us to do it. So the data reader is the equivalent, data reader, data writer, nice and easy to remember. Equally as simple. We new up a reader and we pass it an input stream because it's the data coming into the phone. And what we have to do is we have to load the data into memory. So we need to know how much memory to actually take off the buffer. So in this instance, we're going to say 4 bytes of data because that's the size of an int32 because we know we're passing an int32 backwards and forwards. If we're passing a string backwards and forwards, what we'll normally do is we'll pass the metadata first, and we'll actually pass the length as an int, and then we'll read the int, and then we'll request the length of the string to come off the buffer, and then we'll just continually pass that backwards and forwards. Again, helper method handles all the deserialization of the incoming streams, so we can say reader, read int, reader, read string, and so on. And again, we have a whole load of different options that we can pass in if we want to start customizing the way information is being read as well. These are very, very simple APIs, and these don't just apply to the network stack. They apply, this is the same stuff as I was showing the guys yesterday for writing to USB, writing to HID devices, point of sale devices, any type of Windows RT stream connecting to peripheral devices or the network uses exactly the same API. So data reader and the stream socket is universal across everything. And my green boxes. We have to make sure we close it as well. So being good developers, we need to close everything on tombstones, app suspension, when we've finished using it. If we don't close it, it will continually maintain that connection. So especially on the phone, this is important because if we're pushing stuff backwards and forwards over the network, we could potentially be using 3G data, also using power. But also if we don't close it, it will cause the app to crash. You'll get an unexpected exception to happen, and you'll see it in all my demos because I very rarely close the stuff in my demo code, and it just crashes all the time. And I'm constantly having to restart the app to actually get new connections, and sometimes it can crash out the actual network drivers on the phones if you try to open too many connections as well. So socket.close. The simplest network socket is HTTP. And I say this because I've shown you the UPnP stuff. The UPnP stuff is great, but a lot of hardware developers now actually move into HTTP because people are more familiar with that. And a great example of this is actually GoPro. So the guys that wrote the GoPro Hero 3 app on Windows Phone, which is a great app if anyone has GoPro devices, they've had a really easy time because all the Hero 3 does is it has its own inbuilt Wi-Fi access point. You connect the device to that access point, and it has a set website it exposes, and that allows you to control the camera. And then you just open up a HTTP style media stream, and you can start streaming down the frames to the device, which means you get this HD camera output onto your phone device. It's very, very easy for them to integrate into what's a quite complicated device just using their knowledge of HTTP. I didn't work on this project, but I know the guys that did, and they didn't require any external help. Other products that offer similar APIs, the quadricopters, most of them have inbuilt wireless access points and are using HTTP. So you can actually control the whole thing over web server connections, but you actually get There's a couple of UDP bits on there, like the video stream is a UDP, and the emergency cutout is UDP because it's easier for the device to intercept a UDP and cut the HTTP transmissions. This one here is an interesting one, the Philips Hue. This is a light bulb, so you can plug into just a generic light bulb connector, but it actually connects to your home wireless, and you can change the colors and dim the lights and all that kind of stuff. Again, another HTTP connection. Each individual light bulb connects to the internet. So you can be anywhere in the world and start controlling your home lights. And there's loads of these devices. If you spend any time on Kickstarter or anywhere with devices, you'll start to see them popping up, and HTTP is becoming more and more prolific as a method of communication, especially as we turn into this Internet of Things. I showed a demo last year at TechEd New Zealand around a fridge magnet. There was a company in Dubai that wanted to encourage people to order more pizza. They were a pizza company. And they actually built a fridge magnet where you stuck it on your fridge and you connected it to your home access point, and then you went onto their website and said, I want to be able to order this pizza by pushing this fridge magnet, and it's actually a button. So every time you got hungry, you could just push the panic button on the fridge and it would hit the website and order pizza. So we're seeing more and more of a device ecosystem that's using HTTP. So just to quickly summarize the sockets before I move on to the next technology stack, highly recommend WinRT, the WinRT APIs. They're extremely simplified and extremely powerful at the same time. It does everything I've needed to do to connect to any device. I've never had to deviate away from back to C# APIs, because even though they are simplified, they cover most scenarios, and they're universal, so you learn one and you can apply it to anything else. We do have the .NET API, so if we're doing something maybe in a PCL, and we're going to attempt to move across various devices, .NET is still supported, also for legacy Windows Phone 7 stuff as well. The WinRT stuff is portable into C# apps on Windows 8, but it's limited to Windows 8 because of the WinRT APIs being baked into that operating system. WinSock is there as well. We can't bring the WinSock APIs across to Windows 8, but if you are a C++ developer or a game developer, we have the WinSock stuff there. Because a lot of the guys porting from iOS and Android, that's how they're actually communicating with stuff as well. It's a standard that's come across. Okay, proximity. This is a technology I was pushing and pushing and pushing last year. It's one that, it's a great technology on Windows 8, and we finally got it on Windows Phone 8. I knew it was coming on Windows Phone 8, but I couldn't talk about it last year. And proximity is actually an aggregation of all of the stuff I've talked about so far, but actually simplifying, again, one step further, allowing you to kind of communicate between devices. And it actually moves beyond just simple network stack. It actually moves into a couple of different technologies. And we have near-field communication, which is a short range, it works mostly about 10 centimeters, so you have to be like contact technology. It's very low protocol because it's designed to be low power. The credit cards and stuff like that, they're read via magnets, so it's not going to pass information in a very fast way, but it's great for bootstrapping information. So when I was showing you the demos earlier, I was having to type the different IP addresses of the phone as it was exposing them to the client. Whereas this, because we can send a little small burst of information, we can do the whole tap and pair. So we can go into a printer and we can tap our phone against a printer, and the printer can tell us its IP address in a short burst of information, but very, very small bursts, because it takes so long to actually send that information. We have access to Wi-Fi within the proximity stack. If you're doing tablet-to-tablet communication, we have two different forms of Wi-Fi, and I talked briefly about this yesterday. You have Wi-Fi infrastructure. You also have a concept called Wi-Fi Direct, and I done the demo yesterday using Miracast, built upon Wi-Fi Direct. Wi-Fi Direct is a peer-to-peer technology, which we don't have in Windows Phone 8 yet. I'm really hoping we see it soon, because it's great. It's in Android, and it's really effective. For Windows Phone, though, we do have Wi-Fi infrastructure. What that means is if two devices are on the same access point, we can leverage the proximity stack to actually open a connection for us and start talking to one another. The last technology we have is Bluetooth. And we have Bluetooth in app-to-app scenarios, and we have Bluetooth in app-to-device scenarios. So it means that we can also talk to Bluetooth peripherals, so we can start talking to our robots and our wristwatches and things like that. Like I said, this was a little known fact, and even the Nokia guys still get confused around what we have access to in Bluetooth, because it's not that well documented. It's wrapped in a managed API, and it's a little bit different from the RFCOM stuff that was exposed on Windows 8.1. It's not a direct, let's open a Bluetooth connection. It's let's open a proximity connection, but we're specifically looking for Bluetooth devices. I actually forgot to fill this slide in, so it's a slide I deliberately left blank. NFC and wallet is something that was pushed on the Windows Phone 8 launch, but it's something we don't actually have yet in Australia or anywhere else in the world apart from France. So if anyone's worked with NFC, we have this capability within Android and within Windows phones to actually load our credit card information onto what's called a secure element within the device. So it's a protected area of the phone. And using NFC, we can actually start interacting with the contactless card readers that we're starting to see all over the place now. So that technology does exist within Windows Phone. I'm not going to cover it because the APIs aren't generally available. They're only available under a TAP agreement that Orange in France has with Microsoft, and they're the guys trialing it at the moment. So I know a couple of questions has come up about this in the past couple of days, but I'm hoping we start to see more information over the evolution of phone in the next few months around wallet. But it is a capability that's baked into all Windows phones. All Windows phones by default have to have NFC, and they all have the secure element capability to allow us to do this. So hopefully in the next year or so, we'll start to see more good stuff around that. So proximity. I'm going to show a couple of demos in this. The first one I want to talk about is the tap and connect scenario, because when we're trying to connect these two devices together, it becomes very clunky to bootstrap everything, write your IP addresses and that kind of stuff. And especially when you're actually dealing with tablets as well. I've written a couple of companion devices for Windows Phone to tablet. So maybe I've got my Surface, my Windows RT device, and I'm doing like movie editing or something like that. And I want to be able to go out and I want to capture some shots on my phone, and I want to get them across to my tablet. And I want to have this companion experience. So we're building an app for this, we're building an app for this, but they're meant to seamlessly join together. And specifically, again, if you was in my session yesterday, I had this big computer, social interaction between devices. If we all sit around a device and we're engaging with this device, it's great, we have a communal space. But what if we want to have a private experience while engaging in that space? So a good example of this is if anyone was playing poker with me on Tuesday night on this big computer, we all had to kind of grab around this, we gather around the screen, but we was kind of putting our hands over little parts of it so we could hide the information from other people for us to be able to engage in the games. The tablet companion experience is something that it hasn't been explored too much within Windows yet, but the sharing of the APIs means that we can have this experience where I can tap and pair my device against the tablet, and then I've got a second screen in my hand, very similar to the smart glass experience, but that screen has a socket open to that tablet, so I can start maybe seeing my playing cards on my phone and then pushing them down onto the tablet device, so we're actually sharing as a shared experience. So that was actually a pretty good segue into the demo I'm about to show you, where I built a poker game and I'm going to put the cards on the phone. So again, I'll switch back to my computer. And jump across to the demo. I actually have no idea how to play poker. So if you was playing with me the other day, you'll work out I just randomly push buttons and things like that. So I actually cheated and I downloaded a poker library off the internet. You can get some C# ones. And I've just actually converted it across to a Windows 8 app. So if I run the app locally on my machine, it's not going to do anything actually because I need to run it on this tablet for NFC. So again, it's going to be an interesting one because I'm going to need an internet connection to deploy. Okay, so what I'm actually going to quickly talk through is the tap and pair code and how we actually bootstrap this bootstrap the session between the tablet and the device, and then how we open the socket and start passing that socket information backwards and forwards. So what I actually have here, this is Windows 8 code. The code is entirely transferable between what I've written for Windows 8 and what I've written for Windows Phone. They share the same APIs, so nice and easy. So first thing I have to do, I'm now in the windows.networking.proximity namespace, and I'm using a static object called a peer finder. So all of this proximity stuff is essentially based around the concept of peer-to-peer. No one device knows about one another, although maybe they're connected to the same access point. So in the peer finder, I can actually specify which technologies I want to use. So in this instance, I'm saying we can either use Bluetooth or Wi-Fi infrastructure. I've disabled Wi-Fi Direct because Wi-Fi Direct is not enabled on the phone, and I don't want other tablets to start connecting via Wi-Fi Direct. What I've then done is I've actually locked the app down to actually looking for my specific Windows Phone app. There's two benefits in this. Firstly, it prevents other apps hijacking my sessions. The second is if I don't have the app installed on the phone, when I tap it against the PC, it'll actually just push me straight to the App Store and say, would you like to install this app, because it's what the PC is asking me to do. So it's actually great for marketing your app and making sure that a companion is installed, but it's also a security thing as well. Next, I'm just saying I want to subscribe to an event that says a connection has been changed or a connection has been triggered. And then I start my peer finder. That starts a thread in the background, and it opens up. Opens up the NFC bits and pieces. Also starts polling and waiting for incoming connections to occur. When I get the event raised, it's actually an enumeration that's passed to me in the argument, and it tells me whether the device is connected, attempt to connect, failed, and a whole different array of states. Specifically in this example, I've been lazy, so I'm just looking for the connected state, but I can actually provide progressive feedback to my UI if I was saying now connecting, waiting for connection, connection failed, all that kind of stuff. That's all that's actually required for me to connect to that device. I get the socket back in the argument. I can then just jump straight down and say, okay, I've got a socket back, I'll send a message, and in this instance, I'm using JSON.NET to then just start writing JSON back to that socket. Exactly the same code exists in the phone. So exactly the same. The only difference is I've changed the way I've bootstrapped the code to actually say the phone can only talk to a Windows app. So I've now got a Windows app ID in there. Everything else has remained the same, and I've even just copied and pasted it across. The difference is I'm reading on the incoming argument. So I actually start a new thread, or I don't start a new thread, and I just stick a loop in, and I said why the device is connected, just start looping around and reading incoming data off the stream. So I'm going to run this on my phone, and I'll just show you exactly what happens when I start connecting these devices together. Okay, so I'm just going to debug to the phone. The app's already open on the screen. What I'll actually do is I won't project it. I'll just try and hold it up because it's not overly interesting in terms of UI, and I want to show you how quickly it is to get this information back again. So this scenario is on my screen here. I've just got the standard green poker deck, a green poker playing area with a deck of cards. I haven't dealt anything yet because I don't have my players. So normally I would present a UI to say to join the game, tap and pair my phone. Okay, I've now also got the same green screen just loaded on my device here. So nothing on there at the moment. I've got a breakpoint in this code that hopefully you can see. So as soon as I get a connection to this device, it'll actually send me my cards to then render on the screen. If all goes well, which likely is not going to happen now in this demo, I'm going to tap it on my screen. It's going to make a noise to say it's using NFC to pair, and within seconds, it will open up a socket without me actually doing anything. So if you actually look at the output at the bottom, you'll actually see it failed. It's attempting it. Yeah, it's not going to happen. The main reason is it's actually a fault of, again, the wireless, because it's trying to use the Wi-Fi access point. If I change the code to say Bluetooth only, it most probably have a better time. But I'm having real difficulty getting across the whole Wi-Fi infrastructure here to get sockets between devices because it's such a complicated access point. The fact that it actually said failed means that the two devices talk to via one another with NFC. And it attempted the connection, but it then couldn't sustain the actual socket. This is going to be a real shame because I can't show my final demo, and that was my favorite one. See, it failed again. Essentially, what should have happened is it should have just hit that breakpoint straight away. It should have bootstrapped, opened up a socket, jumped straight into here, deserialized the JSON, and I should have got an array of playing cards, which I could then start putting on the screen. That socket's a two-way socket. It's a fairly fast socket, especially if it's on Wi-Fi infrastructure rather than Bluetooth. And it means I can actually start streaming information pretty quickly. So if I wanted to have a game, I can actually use it very responsively to start pushing commands backwards and forwards to interact with that game, or a poker game. Or in an enterprise scenario, being able to go into maybe a kiosk or something like that and being able to tap my phone and interact with the kiosk remotely based on information I've personalized on my phone. So very, very easy API to build these companion experiences for a tablet. This also works tablet to tablet or phone to phone. So if you wanted to pair two phones together and done a two-player game, you can use exactly the same bootstrapping and it just works. There's also abstracted APIs for this. Qualcomm built one called AllJoin, which works across different technology stacks. So it works across iOS, Android, has Unity 3D plugins. And what that does is it uses the stuff within the Windows RT namespace, but builds another layer upon that to aggregate across all the different devices that connect to it and actually provides a service bus style infrastructure. So you can pass messages onto a service bus and start bouncing them backwards and forwards between maybe an iOS device and a Windows Phone device. Really good if you're building games in something like Unity 3D because it just exposes a common API that you can develop against and you can ignore what infrastructure it's being deployed on. Okay, so just a quick summary of that code. We turn the peer finder on and we just define what technologies that we want to use. We then actually give it the alternative identity that we want to connect to. We subscribe to the argument, and that argument will tell us when the devices start connecting and the status of them connections. So as in the example here, it listened and it failed. It should listen and it should connect. And then there's a state of connecting as well, so you can progressively show the UI. And then we just call peer finder to start, which actually starts the polling in the background and it runs on the background thread. So that's Bluetooth sockets. Bluetooth RF com socket. So this is the next level of these same APIs. So the same peer finder actually allows us to then connect to Bluetooth RF com. So RF com exposes itself within Windows Phone purely in the serial port profile, means we can't start connecting to audio devices and stuff like that. But a lot of the devices that we do have access to, like the Sphero, is actually just a serial port profile, Bluetooth 2 connection, so very, very easy to connect to. If you've ever used serial ports in the past, RS-232 serial ports, exactly the same concept. You're just passing raw data over a wire backwards and forwards, apart from this is now wireless. So we can actually use exactly the same code. That's the wrong demo slide, but I'll just quickly jump into a Sphero demo. Hopefully this being Bluetooth, it may work. And I've got to change my machine around. So if you came to our session on Wednesday with Vaughan when his demo broke because he was suffering the same pains as I'm suffering this morning, we talked about the Sphero and the Moga being two common devices we're starting to see in shops in the US now as peripheral devices for primarily, they were started to be marketed for Android, and now a lot of the stuff's been ported across to Windows Phone. Sphero's a little robot ball. You've most probably seen me driving it around the showcase. They're great little devices, they're like $100, but it's two-way information, so we get information back from the Sphero. It's accelerometer, gyrometer information. We can use it as a game controller, or we can control it and make it move around the screen and change color and things like that. Originally, these guys wrote Unity plugins and that kind of stuff, and we decided to port it across to Windows Phone for these demos, and now all of this code is on the internet. So this is actually the Sphero API that I'm going to quickly jump into and show you the code. So exactly the same as what I just showed you in terms of pairing the two devices together. The only difference is instead of us saying the alternative identity is a Windows Phone app, we want to say the alternative identity is a Bluetooth paired device. That means I've gone into settings and Bluetooth on my Windows Phone and I physically paired the device. I can't pair the device from within an app. A user has to consent to that device to be paired, so you have to go in, connect it up all yourself, and you can provide instructions to a user with that on the screen. You can also, if you attempt this connection, and it will throw a specific exception with a result, and that will say Bluetooth is not enabled or Bluetooth or the device isn't paired. So you can actually detect whether the devices have been paired that you're specifically looking for. From there, we just launched the peer finder, and we're actually using the peer finder find all peers async. So this is instead of it being an event-based system, this is us just now saying just tell us everything that's connected to the machine using an async call, and it gets the device back again. When we've got the device back again, we've got the socket just attached to the device object, and we open the socket using the data reader, data writer, and because I've worked with the Sphero guys, I know all the commands to pass backwards and forwards to this device, so I just start writing byte arrays to the device, and it makes it change color, which means that I can take my Windows phone out, and I can go in. It'd be really good if I could project this one, but I can't hold it and project it at the same time. Make sure my Bluetooth's on, and then I'll go into the Sphero app. Connect to the particular Sphero. You'll see it go into a constant color if it works. So it's constant color. I can put it on the stage, and then I can start driving it around the stage. So nice and easy, just passing byte arrays via a data writer. Very, very easy to do, exactly the same code as I've used in all of these demos before, apart from now I'm writing to a physical object, and the physical object is responding to me. What I wanted to show, and it's not going to work, so I'm not even going to attempt to embarrass myself, is I've got exactly the same connection to this device as I have to the watch on my wrist. My tablet is connected to this device on the Wi-Fi access point. So as of yesterday, when I was in the showcase on my own and the Wi-Fi was good, I was actually 10 meters away from my robot arm, and I could start moving the buttons on my wristwatch and start controlling the robot arm that was on the opposite side of the room. I'm using the device in my pocket as an aggregation hub for other devices as well. So I'm actually now starting to mash up the devices I have access to and create new experiences. The personal wearables is becoming more and more significant for this type of stuff, especially this week when we've seen gear get released. It means that big manufacturers are now starting to take notice of people want devices smaller, more portable, so we're getting more opportunity to do this kind of stuff. So I can use the wristwatch on my wrist to change the channel on the TV by using a UPnP connection that I've shown you and how to do the broadcast stuff with 4 or 5 lines of code, and a peer finder connection to my wrist, just all connecting via my phone. I don't even need to take the phone out of my pocket. As long as I know the Bluetooth's on and the device is already paired, I can load the app up and just start moving things around. So that's the message that we've been trying to get across for the last couple of days. The Sphero stuff, the stuff yesterday, is we want people to start experimenting with what's in their house, what's in their enterprise. The socket stuff is easy. It's been engineered a lot easier because there was a high barrier of entry before when people wanted to start integrating with devices. We've simplified it. We've given you access to other technologies. In Windows 8.1, we've got USB, we've got Bluetooth, we've got Bluetooth 4. In Windows Phone, we've got Bluetooth SPP, and we can now communicate to a whole load of new devices. We can use the network stack. We can use HTTP. We can start calling stuff out to the internet. So when we start thinking about our apps, we now need to think about our apps in a bigger ecosystem of not just what's on the screen at the time, but maybe what's on our tablet and how our tablet app can communicate to our phone, how our phone can communicate to our watch, and how our watch can communicate to the average robot arm we have sitting in our house. So this is the end of my session, and I just want to make sure that people now fully grasp the world of connected devices. Hopefully you've learned a little bit about it, and hopefully I've inspired you to go home and start looking around your house and seeing what 2 devices you can pair together in your app. So that's it for my session. These are a couple of good little open source libraries if you need helper classes and stuff like that. But I think I've got 2 or 3 minutes for questions before I have to run off and jump on the plane. If you don't want to ask questions here, you can hit me up on Twitter, email me. Just go and ask for my details in the dev den, and I'll happily pass them on to you. So any questions?
Are there any security implications with these kind of connections? Like, is it easy to secure these connections?
I'm sure someone somewhere will tell me that NSA can watch everything that my robot ball is doing and driving around, but We can enable the SSL sockets, which provides us the same security as we would get passing the information up to the internet. So we can do that. We can also make sure if we're connecting two devices together, our code is dealing with security, so the payloads are actually doing obfuscated in some way. So we may be using hashing or encryption or something like that. So yes, there are security, especially when you're passing stuff across public Wi-Fi access points. It's exactly the same as if you're just passing information between the internet. But a lot of what we're passing is basic command style information. It's not like we're going to be passing your bank details backwards and forwards to a robot and things like that. It's going to be like integer values of where a thing is in the room and stuff like that. So it's not too much of an issue. Biggest one I've seen is someone thought it was a bright idea to hook their door lock up to the internet, and it was a project on Kickstarter where you could actually just unlock your door with an app, and that seemed like a huge security thing for me. But people want to do it. People want to put their doors on the internet and allow you to unlock it. So, yeah. Any other questions? Okay, guys. We've got mostly 10 minutes or so to the next session, so go and take your chance, get a coffee, and if anyone wants to have a chat, I'll be heading off in about 10 minutes or so. Thanks. NetDuino? Yes, I done